Hi, I'm Caroline. I study glaciers and water at McGill University, and today I'm going to talk about how multidisciplinary water research can bridge the gap between data and people. So to start with, we're all researchers, and we are all incredibly specific. Our research project really only looks at like a tiny little bit of the bigger research question we're trying to answer. And if we want to advance knowledge and create new knowledge in a certain field, well, that is probably the way to go. And really, we shouldn't be surprised about that, because we do start to specialize very early. I picked how much science I wanted in high school. And then, undergrad, you pick one topic, and then grad school. You really get into the tiny details of this one topic to try to find new data. And, well, this is where it leads me. I'm really good now at looking at infrared images of that one glacier in Peru for a period of 33 hours. That's quite very specific. But really what I'm trying to look into is the water resources in the region. By myself, there's no chance I can answer that question, because really 33 hours for one glacier, it's not enough. Luckily enough, I'm part of a multidisciplinary research group that comes from a various of backgrounds. So last summer in the field, there was 10 of us from 4 different universities that have a background in atmospheric sciences, geology, groundwater hydrology, physical geography. And between all of us, even though we're incredibly very specific, we are starting to draw a pretty good picture of what's happening in that valley. So for example, my colleague, Lauren, over there, that talked yesterday, is looking at the river below my glacier. So my glacier is in the background. That's the river she's studying. And our other colleague, who had a poster today, or yesterday, it was really good also, she's doing seismic experiments to try to see what's happening underneath that river. So for that valley, we have a pretty good picture of what's happening now that we've been studying for multiple years. And it's really good that we're such a large team, because one, it does make conversation at dinner in camp a lot more interesting. And also, we all have insights and ideas that do complete each other. If you had told me that the girl running seismic experiment would give me a key piece of a puzzle to solve how I was going to set up my instruments on my glacier, I wouldn't have really believed you. And that's where my first insight come in, which is there's so much room to learn from your peers. Even in one discipline, even for example in physical hydrology, talk to your coworkers, because they run into the same problem as you and they often figured it out and they can help you. But then, even though we understand pretty well what's happening in that one valley, we start hiking around and we have cows trying to eat our instruments. It's a grazing land, there's villages in the valleys, and then we go lower and we're in the city that heavily relies on the water coming from the mountains and the valleys in the background. And that's where I realized that really, even though we're a multidisciplinary science team, we really only look at one aspect of water. We're really only looking at the physical side of it. And to really understand what's happening, we need to include the social side. And that's where the second part of my multidisciplinary team comes into play. We have a really strong collaboration with social scientists. So the first day I showed up for fieldwork, I sat down with my PI, and he was like, "What are you studying here?" And I was like, "Climate change, water contamination, surface water, groundwater interaction." And his answer was slightly more complex. We started talking about the people that live around there, and how the politics in the country affect the water resources, and how the locals perceive us scientists coming there and doing research. And why, for example, people live in the locals still live in that area, even though there's an incredible risk of natural disasters, like what happened in 1970 when an earthquake created an avalanche that buried a whole town. So really, to understand what's happening in those landscapes, it cannot only be physical scientists. You have to include the social science. And really, does that make my science better? I don't have more data. I don't learn a new analysis technique. My paper is written pretty much the same way. The only difference is that now, when I start my talk saying, climate change will impact the population living downstream, I actually know what it means, and I actually understand the wider background, which is my second insight. It's really important to understand everything else than your data set. We're all incredible scientists, we're all AGU. There's probably other scientists that are not here that are also incredible, but it's important to understand what's happening behind your science. We all try to study water because we think it's important, and it is in the future. It's really important to understand what's going to happen with the water resources. But if we don't understand the social aspect of it, we're going to end up missing out on a very important part of the water, which is the people that are using it. Thank you.